we're going to look at a famous mathematical pattern, and you can see it here, 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. And if you've never seen this pattern before, it may not even look like a pattern at all. What you want to look at is, if you look at the fourth term and the fifth term here, if you add them together, you get the sixth term. 3 plus 5 is 8. Or if you take 5 plus 8, you get 13. Or 21 plus 34, you get 55. And so this pattern that is defined by saying that the next term of the sequence is the sum of the two previous terms. And this is given the name the Fibonacci sequence. So we're going to try to write a loop to model the Fibonacci sequence. And it requires several variables to keep track of the relationships that we see in the pattern. So the first thing we're going to need is a variable called current, which is going to keep track of kind of the current number in the sequence. We also need to keep track of the previous number, as well as what I will call the two-back number. So at the beginning, the previous number is the number 1, the two-back is the number 0. So that's kind of where we begin with. This is 2 back from this term, and this is 1 back from this term. And these are their values. Now we're going to have to start a loop, which we'll fill in the signature for later. And in this loop, it needs to evaluate that the current number in the sequence is always going to be the sum of the two previous. So current will be set to be the previous number plus what's 2 back. And then if we want, we can print out what that is. Now where we have to be careful is that after we get done printing out current, we need for the next time the loop runs for the previous and two back variables to be moved. So what I mean by that is, for the first time through, previous and two back are 1 and 0. Great. That'll mean that current will be 1, and we're set up wonderfully. But for the next time through, we want current to become the sum of this previous and this next. So that means the previous and the, two back. So the previous and the two back variables should have moved up one spot in the structure of the pattern. How can we get that to happen? Well, we need the two back variable to be changed now. And two back, which was now here, needs to take on the value that is right here. So that means it needs to take on the value that is in the previous spot. But likewise, previous needs to be moved up to the value that's in the currently calculated spot. And so this will correctly shift these two values to the next two spots in the pattern. All right, the next thing we need to do is to kind of put in the loop signature. So if you notice, the first current that I'm calculating here is starting at n equals 2. So that's what I should make my loop body, starting at n equals 2. Can't spell previous right. All right, then I have to decide kind of which term I want to stop in the pattern. So I'll go up to the 20th term just to see what that is, and have n keep going up by 1. And to make it clear which term is being printed out, I'll add this little add-on. And let's go ahead and run and see what it does. And here you see a bunch of numbers popping out saying the second term is 1, that's right. The third term is 2, the fourth term is 3, the fifth term is 5, great. And then down here the 20th term is 6,765. So it looks to me like our algorithm is working pretty well. It is pretty tricky to get this set up the first time because you have to be moving these other two variables. So don't be freaked out if that's like, wow, I would never have come up with that on your own. One other thing we might be bothered by is we're not getting the 0th term and the first term to appear. So I just need to print those out manually. It's not too big of a deal. So the 0th term is 0, or I can use the variable 2 back. And then the first term will be what's stored in the previous variable. And now if I run it, I will get the full sequence of numbers that represent the Fibonacci sequence from the 0th term all the way to the 20th. So hopefully this strategy makes sense.